Hello everyone, my name is Abhishek Maurya and I am a student of Integrated MSc Physics 3rd year IIT Roorkee. Today we are going to find first 10 terms of an arithmetic progression on 8085 simulator. First we will see the working of a code on a flow chart, then we will see a implementation of a code GNU Sim simulator. The explanation is such that we are given an initial term of an AP, common difference of a AP, and n up to which term we have to find all the elements of the series. In our example, we have taken a equals to 10, d equals to 2, n equals to 5, which means we have to find first 5 terms of an AP with common difference of 2 and initial term of 10. After doing the maths, we get 10, 12, 14, 16 and 18. As you can see, each and every number has a common difference of 2 with its neighboring number. In the code, first we are going to store the data of an A, D and N in the registers. Second, we are going to create a memory location where we are going to store our every element. Then we will create a loop so that we do not have to write the code over and over and we can do it easily. First, after creating the loop, first we will add a B, which is common difference, to the accumulator, which is our initial number. Then we will decrease n by 1 because we have find our first element. Now we have to find our next n minus 1 numbers. Then we will increase the address of D by 1 so that we do not rewrite our next number on the previous number. After this, we will check the value of n. If n is not equals to 0, which means we still have to find our remaining numbers of the series, and this will lead us to the starting of the loop, and then the loop will go on and on until the value of n becomes 0. When the value of n becomes 0, then this means we have find our all number of the series. Now we can stop the loop. Here you can see the implementation of a code in GNU Sim. Now we are going to implement the code line by line and we are going to check the results one by one. As you can see, I have already written the code. Now we are going to execute the code line by line so that we can check the progress one by one. Now in this line, we are storing the initial term of the AP in register A. As you can see here, before executing this line of code, the value of register A is 00, and after executing, the value is 0f, which is basically means 15 in hexadecimal. Now in this second line, we are storing a common difference in the register B. As you can see here, it is 00, and after executing it becomes 0a, which is 10 in hexadecimal. Similarly, we are storing our n, up to which we have to find all the elements of the series, which is in our case is 6, and it gets stored in register C here. Now in this line, we are creating a memory designated to address 1. Now in this line, we are using the syntax tags D, which is basically means transfer all the data of accumulator A into the D. Now after executing this, we will get our first element of the series. As you can see here on the right side in the memory tab, here our first element 15, which is being stored here. Now in this line, we are going to increase the address of D by 1 so that we do not overwrite the next element on the previous one. As you can see, after executing the previous line of code here, the value of D became 2, which means we are now going to store the element in the next address 2. Now in this line we are adding a B to the accumulator A. As you can see here, the value of accumulator A has been changed to 19, which is basically means 25. Now we are going to decrease the value of C because we have already found our first element. Now we have to find our n minus 1 in our case, which is 5. Now we have to find our next 5 element. That's why C is 5 now. Now we are checking the condition for termination. As we can see here, C is not equals to 0, which means we still have to find our 5 remaining elements. As you can see, it have already jumped to the starting of the loop. Now the loop will run until the value of C becomes 0. As we go ahead, you can see that the values of our terms of AP are being stored here, and the values of C is decreasing every time we complete one loop, and the value of D is increased by 1 because we are storing it to the next address. Two elements left. Now after executing this line, the value of C will become 0. As you can see here, it is 0. Now the value of C is 0. The program will get terminated here. And as you can see, we have find our all the 6 elements of the AP progression. Thank you for watching the video.